Okay, here we will discuss what do you mean by principal stresses and principal planes in three-dimensional stress system. In SOM, you have studied a two-dimensional system, but here we are going to take three-dimensional. So, what do you mean by principal plane? So, if you have any object, something like this, you will have a body like this, three-dimensional object like this. This three-dimensional object will be subjected to some external forces. Due to that, stresses will develop. Okay. Now, this three-dimensional object will be having three planes. One may be like this, another may be like this, one more may be like this. Three different planes it will have, on which only normal stresses exist. Shear stress is zero. ಅಂದ್ರೆ ಪ್ರಿನ್ಸಿಪಾಲ್ ಪ್ಲೇನ್ಸ್ ಅಂತ ಏನರ್ಥ ಅಂದರೆ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಅದರಲ್ಲಿ ಅದ್ರ ಮೇಲೆ ಜೀರೋ ಇರುತ್ತೆ. ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಆಕ್ಟ್ ಆಗಲ್ಲ. ದೇರ್ ಇಸ್ ನೋ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ದಿಸ್ ಪ್ಲೇನ್, ಬಟ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಓನ್ಲಿ will exist. For example, here I have taken like this. So this is three-dimensional object. I have shown x, y, z axis like this. So I have shown three planes. This line ತರ ತೋರಿಸಿದ್ರು ಕೂಡ, even though I have shown it as a straight line, it's a plane. Plane, but two-dimensional. So this is one plane, this is another plane, this is another plane. There are three planes. Because it is three-dimensional, you will be having three planes. If it is two-dimensional, you will be having two principal planes. It is three principal planes. Okay. So here, the meaning of that is, on this, suppose if I take plane 1, on this plane 1, it will have normal stress component. Normal stress component on plane 1, I am taking as sigma 1. But what about shear stress? Shear stress is zero. Very important. Shear stress zero is not plane ಮೇಲೆ. Only normal stress ಇರುತ್ತೆ. Here I have shown normal stress tensile. Tensile ಅಂತ ಹೇಗೆ ಹೇಳ್ತೀರಾ? I have shown away from the plane. If the arrow is away from the plane, it is tensile. Correct? Away from the object is tensile. Towards the object is compression. Second plane I have put it like this. On the second plane also shear stress is zero, and it will have normal stress something like this. So here also I have shown normal stress as tensile. Third one, it is like this. Third plane is like this. On this plane also shear stress is zero. Normal stress I have shown compression here. ಯಾವ್ದಾದ್ರು ಆಗ್ಬೋದು. In a given problem, all the three may be tensile. Sigma 1, sigma 2, sigma 3. If you get all the three positive values, then it is tensile. If all the three negative values, then it is compression. One of them may be positive, two of them may be negative. So we cannot say whether all the three are positive or all the three are negative, or one may be positive, two may be negative, or two may be positive, one may be negative. There are so many combinations, correct? So depending on whether you are going to get positive or negative value, you can judge whether it is tension or compression. Anyway, what you have to learn here is, in any three-dimensional object, when it is subjected to external forces and when stresses are developed within the body, normal stresses and shear stresses, you will be having three imaginary planes. Three planes will be there, on which shear stress will be zero, only normal stress exists. The plane on which shear stress is zero and only normal stress exists, such types of planes, such a plane is called as principal plane. And the normal stresses which act on those principal planes, they are called as principal stresses. In the sigma 1, sigma 2, sigma 3, they are called as principal stresses. And 1, 2, 3, what here I have shown, they are called as principal planes. So on this plane also, show shear stress is zero. On this plane also, shear stress is zero. On this plane also, shear stress is zero. But normal stress will be. That is the condition. ಇದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಎಕ್ಸಾಮ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಅದಕ್ಕೆ ಪ್ರೊಸೀಜರ್ ಇಂದ ಬಂದಿದೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ತೀವಿ. ಪ್ರೊಸೀಜರ್ ಏನಂದ್ರೆ, ಯು ನೋ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಸ್ಟ್ರೆಸ್ ಇನ್ವೇರಿಯನ್ಸ್. ಈಗ ಸ್ಟ್ರೆಸ್ ಟೆನ್ಸರ್ ಕೊಡ್ತಾರೆ ನಿಮಗೆ. ಸೊ ದೇ ವಿಲ್ ಗಿವ್ ಸ್ಟ್ರೆಸ್ ಟೆನ್ಸರ್. Once they give stress tensor, so you will be knowing all these values. Correct? Sigma x, tau xy, tau xz. This is also tau xy, tau xz. This will be sigma y. This will be tau yz. This will be tau yz. This is sigma z. Symmetric. This will be given in the problem. Once they give stress tensor at a point, they will ask you to find the principal stresses and the principal planes acting through that point. ಒಂದೊಂದು ಪಾಯಿಂಟ್ ಒಂದೊಂದು ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಇರ್ತದೆ, ಒಂದೊಂದು ಸೆಟ್ ಇರ್ತದೆ. ಅರ್ಥ ಆಯ್ತಾ? ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್, ದಿಸ್ ಇಸ್ ದಿ ಸ್ಟ್ರೆಸ್ ಟೆನ್ಸರ್. Now what we have to do is, procedure is like this. First we have to find out the stress invariance. You know these three formulas. What is your line? So these three formulas, I1, I2, I3. First invariant of stress, second invariant of stress, third invariant of stress. By knowing this stress tensor, just substituting the values and simplifying, you can find out I1, I2, I3. Once you find out I1, I2, I3, you can form an equation like this, cubic equation. How to form? Sigma cube minus I1 sigma square plus I2 sigma minus I3 is equal to 0. ನೋಡಿ, ಆಲ್ಟರ್ನೇಟಿವ್ ಪ್ಲಸ್ ಮೈನಸ್ ಇದೆ, ಅದನ್ನ ಕಟ್ಕೊಳ್ಬೇಕು. ಫಸ್ಟ್ ಪ್ಲಸ್ ಬರುತ್ತೆ, coefficient ಏನಿಲ್ಲ, coefficient is one thing, plus minus that. So ಇದನ್ನ ಯಾಕೆ ಕಟ್ಕೋಬೇಕು? This is the cubic equation. So this cubic equation will have how many roots? Cubic equation is how many roots it will have? ಎಷ್ಟು ಆನ್ಸರ್ಸ್ ಬರುತ್ತೆ ಸಿಗ್ಮಾಗೆ? 3. ಕ್ಯೂಬಿಕ್ ಅಂದ್ರೆ 3, ಕ್ವಾಡ್ರಾಟಿಕ್ ಅಂದ್ರೆ 2, ಬೈ ಕ್ವಾಡ್ರಾಟಿಕ್ ಅಂದ್ರೆ 4. ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ ಕ್ಯೂಬಿಕ್ ಈಕ್ವೇಷನ್ ಮೀನ್ಸ್ you will have 3 roots. So using the calculator, if you solve this cubic equation, you will get 3 values for sigma. Those 3 values are nothing but your principal stresses. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, roots of above equation give the principal stresses. So one value sigma 1, second value sigma 2, third value sigma 3. ಯಾವುದು ಬೇಕಾದ್ರೂ ತಗೊಳ್ಬೋದು, ಅದೇನು ತೊಂದರೆ ಇಲ್ಲ. ಇದು ಟು ಫೈಂಡ್ ದಿ ಪ್ರಿನ್ಸಿಪಾಲ್ ಸ್ಟ್ರೆಸಸ್ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಪ್ರಿನ್ಸಿಪಾಲ್ ಪ್ಲೇನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾರೆ. ಅಂದರೆ ಡೈರೆಕ್ಷನ್, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅದು, ಪ್ಲೇನ್ಸ್ ಅಂದರೆ ಏನಂತ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅದು ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತ. ಇನ್ ದಿ ಕೇಸ್ ಆಫ್ 3 dimensional ಸಿಸ್ಟಮ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಡೈರೆಕ್ಷನ್ ಕೊಸೈನ್ಸ್. LMN ಅಂತ ಹೇಳಿದ್ರೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ LMN we have to find out. How to find LMN for all the 3? ಅಂದರೆ 3ಕ್ಕೂ ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ ನೋಡಿ. ಇದು 1 ಈ ಥರ ಇದೆ, 2 ಈ ಥರ ಇದೆ, 3 ಈ ಥರ ಇದೆ ಅಲ್ವಾ? ಸೊ LMN for this plane is different, LMN for this plane is different, LMN for this plane is different. So that is why what I do is, for this plane I take the direction cosines as L1, M1, L1. For this plane I take direction cosines as L2, M2, N2. For this one I take it as L3, M3, M3. But it moves at different 3 steps per. So one of the find out ಮಾಡಬೇಕು. What is direction cosine? It is the cos of the angle made by the normal drawn through that point with respect to x, y, z axis. Alpha, beta, gamma. In the last lecture I have explained it. Alpha, beta, gamma. Alpha is the angle made by the normal with x axis. Beta is the angle made by the normal with y axis. Gamma is the angle made by the normal with z axis. Cos alpha is L, cos beta is M, cos gamma is L. Like it. Okay. So we have to, let us see first how we can find out the direction cosines for this first plane. So first plane is sigma 1, correct? Sigma 1 plane we will find out the direction cosines. So for on which sigma 1 acts, these are the direction cosines, L1, M1, L1. Now we have to find out L1, M1, L1. So procedure is very simple. What you have to do is, this stress tensor you will be knowing. This stress tensor you will be knowing. What you have to do is, principal diagonal elements, you observe here, principal diagonal elements, you have to subtract sigma 1 from the principal diagonal elements. Sigma x minus sigma 1, sigma y minus sigma 1, sigma z minus sigma 1. All others remain same. Shear stress components remain same. You have to subtract sigma 1 from the normal stress components. That is the first step. Next, after that, we have to find out 3 constants, A1, B1, C1. The A1, B1, C1, how to find here is, these constants are nothing but cofactors in the continuum. Determinant ನಲ್ಲಿ cofactors ಅಂತ ಬರುತ್ತೆ. ಇದು ಮರ್ತ್ಬಿಟ್ಟಿದ್ದೀರಾ ಅಂತ ಕಾಣುತ್ತೆ. Cofactor ಅಂತ ಬರುತ್ತೆ. So how to find cofactor I will tell you. Suppose if you want to find A1, you take the first row. You take the first row. First row elements you take. So, first E element you neglect this row and this column. I am taking this element, you know. Remove this. Remove this. This. Correct? So that you have to write here. A1 is by neglecting, by omitting this row and this column, whatever is left out, that you have to write. That is A1. And how to find the value of this? This into this minus this into this. Problem ಮಾಡೋದು ಅರ್ಥ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ B1 ಅಂದ್ರೆ ಇದು ಬರುತ್ತೆ ಎರಡನೇದು. ಇದು B1 ಇದಕ್ಕೆ. ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ? ನಿಮಗೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಯಾವ ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಮಾಡುವಾಗ ಆಲ್ಟರ್ನೇಟಿವ್, ಪಾಸಿಟಿವ್, ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್. ಈಗ ಸೆಕೆಂಡ್ ಒನ್ ಏನಾಗುತ್ತೆ ನೋಡಿ B1 ಮೈನಸ್ ಬರುತ್ತೆ. B1 ಗೆ ಮೈನಸ್ ಬರುತ್ತೆ. ಮೈನಸ್ ಬರುತ್ತೆ. ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡು? This for this I have to write down. Remove this column, remove this row. Whatever that element will be having in one row and one column, those two common row and column should be removed. So ಉಳ್ಕೊಳ್ಳೋದು ಯಾವಾಗ? tau xy, tau yz, tau xz, sigma z minus sigma. Correct? That is your B1. C1 ಗೆ ಮತ್ತೆ ಏನಾಗುತ್ತೆ? ಪಾಸಿಟಿವ್ ಪ್ಲಸ್ ಬರುತ್ತೆ. C1 ಬೇಕು ಇದು for this. Remove this column, this row, so you will be left with tau xy, sigma y minus sigma 1, tau xz and tau yz. Correct? That is your C1. So that means these cofactors are all second order determinant. So second order determinant value you can find out. Multiply these two minus multiply these two. You will get some numerical values. So A1, B1, C1, they are all constants. You may get positive or negative. Then after that, you calculate one constant K1. K1 is root of A1 square plus B1 square plus C1 square. Then your direction cosines will be, direction cosines of sigma 1 will be L1 is this, whatever A1 you have got divided by K1. M1 is B1 divided by K1. N1 is C1 divided by K1. So ಮೂರು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ನಿಮಗೆ. ಅರ್ಥ ಆಯ್ತಾ? So actually one check is there. What is that check? I told you in last lecture. The sum square, if you square them and add, if you square them and add, you will get 1. Correct? Sum of the squares of direction cosines is always equal to 1. L1 square plus M1 square plus N1 square is equal to 1 ಬರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? L1 ನಿಮಗೆ 0.3 ಬರ್ಬೋದು, M1 you may get some 0.4, N1 you may get some 0.15, something like that. If you square and add, you are going to get 1. So this is, once you get L1, M1, N1, they are the direction cosines of the first principal plane on which sigma 1 acts. Similarly, you can find out the direction cosines of sigma 2 or sigma 3. Sigma 2 ಗೆ L2, M2, N2, sigma 3 ಗೆ N3, M3, N3. ಅವಾಗ ಏನು ಮಾಡಬೇಕು? ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡು? ಸಪೋಸ್ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಫೈಂಡ್ L2, M2, N2, ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡು? ಇದೇ ಪ್ರೊಸೀಜರ್. ಇದನ್ನ 3 ಸಲ ಮಾಡಬೇಕು ಅಷ್ಟೇ. ಯು ಹ್ಯಾವ್ ಟು ಡು 3 ಟೈಮ್ಸ್. ಇಲ್ಲೇನು ಮಾಡಬೇಕು ಅವಾಗ? sigma 1 ಬದಲು you have to take sigma 2. So you have to subtract sigma 2. All the other procedure remains same. So ಅಲ್ಲಿ ನೀವು A2, B2, C2 ಅಂತ ಹಾಕಬೇಕು. ಮತ್ತೆ K2 ಬರುತ್ತೆ. So N2 will be A2 by K2, M2 will be B2 by K2, N2 will be C2 by K2. Similarly, for the third one, sigma 3 ಗೆ sigma x minus sigma 3, sigma y minus sigma 3, sigma z minus sigma 3. Suppose ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಬಂದ ವ್ಯಾಲ್ಯೂ, suppose let us say sigma 2 is negative. ಇದು ಸಾಲ್ವ್ ಮಾಡಿದಾಗ 3 ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಒಂದು sigma 1 10 ಬರ್ಬೋದು, sigma 2 -5 ಬರ್ಬೋದು, sigma 3 8 ಬರ್ಬೋದು. sigma 2 -5 ಬಂದಾಗ ಏನಾಗುತ್ತೆ? ಇಲ್ಲೇನಾಗುತ್ತಲ್ಲ ಅವಾಗ sigma x ಗೆ 10 ಇರುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. sigma 2 -5 ಇರುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ 10 -5 ತಗೋಬೇಕು. ಪ್ಲಸ್ ಆಗುತ್ತೆ, 15 ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಸೈನ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಚಿಹ್ನೆ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಆ ಥರ ಮಾಡಬೇಕು. So that means you have to find out direction cosines for all the three principal stress values, because if you want to define a principal plane in a three-dimensional stress system, you should know three values of direction cosines L, M, N. Two-dimensional problem ಬರಲ್ಲ, ಒಂದೇ ಆ್ಯಂಗಲ್. ತ್ರೀ-ಡೈಮೆನ್ಷನಲ್ ಆದರೆ ನಿಮಗೆ ಮೂರು ಬರುತ್ತೆ, ಕಾಸ್ ಆಲ್ಫಾ, ಕಾಸ್ ಬೀಟಾ, ಕಾಸ್ ಗಾಮಾ. So this is the procedure of finding the principal stresses and the principal directions or planes in a three-dimensional stress system given the stress tensor at a point. ಇದು ಕೊಟ್ಟಿರ್ತಾರೆ, ಇದನ್ನು ಕೊಟ್ಟಿರ್ತಾರೆ, ಪ್ರಿನ್ಸಿಪಾಲ್ ಸ್ಟ್ರೆಸಸ್ ಮತ್ತು ಪ್ರಿನ್ಸಿಪಾಲ್ ಪ್ಲೇಸ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಪ್ರೊಸೀಜರ್. ಇದು ಯಾವುದೋ ಇಂಪಾರ್ಟೆಂಟ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ ಟೆಸ್ಟಲ್ಲಿ ಕೊಟ್ಟಿದ್ನಲ್ಲ, ಇಷ್ಟ ಆಯ್ತಲ್ಲ, ಈ ಥರ ಮಾಡಬೇಕು. ಇದು ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಆಲ್ಸೋ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಿಸ್. ಈಗ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಇದು ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಡ.